Hello everybody. In this part we are going to talk about composition of linear transformation, which is from section 1.8 and 1.9 of the text. The only thing we want to address is linear transformation composition is multiplication of two matrices. So what is composition? So suppose there are two linear transformation, TA and TB. So we can think of there's certain image, and after transform of TB, so you can think of the status or the vectors in the domain of TB as X. Then it may have something like this. It's transformed to another image. So this can be written as TBX. Now after that, for the new image, we may have another transformation. Then that might gives you another picture that is called TA of TBX. And by the twofold transformation, we actually have the composition of TB and TA, which is written as TA open dot TB. So in that case, we can equalize this image after two transformation as TA open dot TBX. So if we read the definition, suppose TA and TB are two transformations, and important thing is TB's range is the same as TA's domain. Then we can talk about transformation. So we say TA composite TB is the composition defined by using this notation. It's actually first act X, act TB on X, and then TA to the TBX. In this slide, we're going to look at one example of composition. So there are two linear transformations are given, and we want to find TA composite TB, which means we want to have, suppose original coordinate is this, then first we act TB, then it becomes 1/2 x1 plus x2, and that's x2. And then again we are going to act TA, which means if we carefully look at the definition of TA, then x1 x2 becomes x1 plus x2 and x2. So the first coordinate after the transformation TA becomes the sum of two coordinates in the original picture. So for TA, the original coordinates are given by this and this. Then the first coordinate should be sum of these two, so which is 1/2 x1 plus 2x2. Now the second coordinate of TA just stays the same. So our definition of TA TB can be written as x1 x2, and this is 1/2 x1 plus 2x2 x2. The next question is, what is the standard matrix of TA-TB? This slide tells us how to identify standard matrix of composition of two linear transformations. So as usual, we assume there are two given linear transformations, TA and TB, and we want to know what the standard matrix of linear transformation composite to each other. And then the answer is it's basically multiplication of two standard matrix A and B. And from here, one important message is that because we know that for the matrix multiplications, AB in general is not equal to BA, so we should have TA composite TB in general not equal to TP composite TA. The order of composition will be very important. Now let's look at this matrix, in the standard matrix of the composite TA-TP given in the previous example. So we had the same problem for TA and TP. And the first question is find standard matrices for TA and TP and TA composite TP. So for TA, if we recall the standard matrix, we should map the linear transformation to its standard basis. So what it means is, for the R2 space, two-dimensional vector space, the standard basis consists of two vectors. One is E1, which is 1, 0, and another one is E2, which is 0, 1. Now for TA, we have, so it's better to write in this way. So if you have something X feed it into TA, and then maybe X1, X2, then it comes up with half of X1 plus X2. Now we first do TP. So if we have TP, then TP is given by half of X1 plus X2 and X2. And then for each E1 and E2, if you have 1, 0, then that becomes, after TP, it becomes 1 half and 0. This is for E1, and this is for TE1, TP E1. And similarly, we can act TP on 0, 1, which gives me 1, 1. So the standard matrix for TP is going to be B, which pack TE1 and TE2 together, which gives me 1 half 0 and 1, 1. Now similarly, we can do the TA. TA says if you have X1, X2 and TA, then it's going to be X1 plus X2 and X2. So for E1, we get 1, 0, and 0, 1, we get 1, 1. And for this reason, A is going to be the box packing these two vectors together. So we get 1, 0, 1, 1. Now what about standard matrix of TA, TP? Then the answer is AB equals multiplication of two matrix 1, 1, 0, 1 and 1 half 1, 0, 1. So we can quickly compute the matrix, product of two matrices, which is 2, 0, 1. Of course, we can verify it actually TATP. So by definition of standard matrix, TATP X is ABX, which is 1 half 2, 0, 1 and X1, X2. So if you compute them, this is 1 half X1 plus 2X2 and this is X2, which is exactly what we have obtained in the previous example. right. This is all about the composition of linear transformation, and the only message that we want to deliver is that standard matrix of composition of two linear transformation is indeed multiplication of standard matrix coming from each linear transformation. Thanks for listening.